Thank you all so much for coming to the continuing celebration of the grand opening of the New Color Innovation Network, a public-private partnership with Santa Fe Community College, FabLab Hub, a contract manufacturing company, and the New Color Network that provides digital badge training for new color jobs. And we're all, if you're going to do anything digital, broadband is an important component of that. Our 3D printers that are beside me, we can monitor overnight because of our Wi-Fi connection and stop them if something goes wrong. And so broadband is a really important part of everything that we do, from our digital design in CAD all the way to post-processing. And we're very lucky today to have Kelly Schlegel with us, who is going to talk about the New Mexico broadband deployment plan. Thank you for coming, Kelly.
Thank you, Sarah. Sarah, thank you so much for inviting me. I'm so excited to be here in the Fab Lab and be part of the Fab Lab network. So all the exciting things that you guys are doing on the cutting edge. And thank you to Sarah for all your work that you do for New Color. It's really, I think, the wave of the future. And really, we owe it to our young people to provide those kind of opportunities. So I'm excited to be part of that. And as we know, all opportunities kind of lead back to broadband, okay? As we know, because everything we do right now in this world is enabled by the foundation of broadband. And I think COVID, as we all know, kind of put an exclamation point on that, kind of really emphasized it, because we've got to do the Zoom calls, we've got to connect universities and businesses, we've got to connect people to people. So as we know, in New Mexico, there's a lot of underserved in the broadband world, a lot of non-served, okay? And if we really want to get to a state of happy, connected people and attracting the businesses and attracting the technical workforce, the workforce that you want to attract, Sarah, if you want people to move here and be part of the New Mexico innovation movement, you've got to have that infrastructure in place to be able to attract them. Okay, and so we see, Mathis and I and you guys here, we see an opportunity where we've got to sort of grab the bull by the horns and take advantage of the federal funding that's flowing down after COVID, things that are happening with the FCC, things that are happening, grants that are available for universities and schools and the school education network. We've got to take advantage of those things right now. And if we don't do it now, we're going to be late, okay? And be able to grab those opportunities and bring the best and the brightest together to solve the broadband conundrum for New Mexico. Okay, so that's what we need to do. So the governor, Michelle Lujan Grisham, is in the process of hiring a director of broadband. In fact, I'm on that interview panel, and we're interviewing Wednesday and Friday, so say a little prayer for us. Okay, but Michelle asked me to step in just in the interim with that void and say, can you help me put a plan together? Can you help me put something together that's more unified and more of a comprehensive deployment plan for the state of New Mexico? What happens is when you have funds available, sometimes you have each, and this is just the reality of competition, right? Is a lot of times you have individuals or companies or municipalities or people with a special interest kind of going out individually to grab the funds. Okay, but what if we could be more powerful? What if we could be more comprehensive? What if we could have a better solution if we came together in a collaboration? Okay, and if we could kind of do a dual-edged benefit of encouraging our New Mexico-grown based businesses, okay, like Optipulse here is going to be represented today, if we could grab a hold of the things that were thought of creatively and with technical excellence here in our own state, bring them together in a collaborative manner, put the minds together and put the hearts together to really build something that can be deployed across the state. That doesn't mean there's a one-size-fits-all. Okay, there's not. Each region has a bit of different needs. But if you can do a flexible architecture and you can do solutions where you have an umbrella solution, an umbrella architecture, and then you can adapt it through ORAN, which is the Open Radio Architecture Network, on things that plug and play together. And you can kind of glue that together to get a good solution for each region. And all 89 schools, all, I think it's 39 counties, right? If you can get that all together so that you can provide what's needed to enable education and enable healthcare and enable new businesses and enable collaboration across the state and get things to where they need to go. Bits and bytes need to go to Los Angeles and Houston and Dallas and all of the commercial centers. So how do we do that in an effective manner? Okay, all the while thinking, how do we encourage business in New Mexico at the same time? Okay, so then so I put this together for Michelle. It was presented to her on May 28th. Okay, so we'll kind of just walk through this for a moment, and I think I can do that, right? Okay. All right. Okay. Pardon? Okay, yep. Okay, so I said, well, Michelle, if we're going to do that, I got to be able to put your vision down on paper, okay? I got to be able to come up with what are the key requirements of meeting this need, talk to you about the current technologies, give you a way to make a decision on those technologies, and start introducing you to some New Mexico-based solutions that are emerging in the state, that are disruptive, that are alternative, that'll make a difference and make an impact to the state. And maybe it's even something that other states, even though we're behind the other states right now, maybe it can be something that other states could model. And we have this extreme opportunity here in that we're the 5th largest state geographically in the nation, but we only have 2.2 million people. So we're very, in certain areas, sparsely populated. So we are like a living laboratory. We're like a place where we can try out New Mexico-based disruptive technologies, try it out here in our remote areas that a lot of states don't have, and demonstrate and give you proof of concept testing that shows you that this can really work on an ORAN technology, and that you can hit the ball out of the park because you're not only serving the underserved, you're not only connected people that aren't connected. I mean, I can't even get a signal in downtown Santa Fe and take my business call. I can't even walk 10 feet from my house and take a call, okay? And I'm not even in a rural community. I'm not even on a tribal land, okay? So what is wrong with this picture, okay? But what if you can not only do that, but you could take the companies in New Mexico and have them be the solution providers? Oh my gosh, you just multiplied exponentially what you could do for the state of New Mexico, okay? So then I said, this is what we need to do. This is what we need to seize. The funds are going to start flowing down, and we need to jump now. Okay, what I told her is that she can be part of this brokering of partnerships. Just like you have a public-private partnership here, she could help enable state, public, private partnerships so that we can get through all the wickets and the hoops for applying for these funds and giving the right solution, okay? And then I want it to be that we can provide a model for other states to duplicate. Okay, so as we know, if we can get this reliable broadband in, it's 33 counties, not 39, okay? If we can get to the rural areas, encourage economic growth, then all of these areas benefit. Healthcare, families, research, education, tribal lands, farms, ranches, public services. And we've got to do it with ingenuity, and we've got that ingenuity here. I think, and my friend Patrick Murphy is visiting. He said, he's only been here a few days, he said he can just feel the creativity when he walks around. We are probably one of the most creative and innovative states out of the Union. So why not bring that together in a collaboration? And I'm going to talk to you in a moment about what that collaboration is and what it looks like. Okay. All right. So these are just kind of some top-level requirements that we've got to, meet we've got to do a pathfinder. We've got to meet the budget. We've got to exceed the data analytics. We've got to be affordable. Okay. We've got to use the ORAN architecture. As you know, we're just very sparsely served, poor broadband access. But you could start to do things that sort of bring the technology together in New Mexico in a collaborative manner, using things that are here on the cutting edge. You've got your normal fiber, okay? You've got your infrastructure that's got to be there. But then where fiber is hard to lay and too many miles to go to, too expensive, you can do things like what Mathis is going to show you in a real alternative disruptive technology, things like photoelectronics that has 1,000 lasers on the head of a pin, okay? Things like high altitude platform stations that can fill in all your spotty areas with microwave without only having 5 platform stations across the state of New Mexico. I mean, innovative, groundbreaking things. Then when you start to bring in some of the grassroots telecoms and ISPs like Sacred Wind, PVT, SBI and Cellular One, and sort of make it so the little guys that care about the rule and not the big guys who've sort of excluded the rule because you can't rule areas because you can't make money, you can really serve the people of New Mexico in a much more innovative and better way. So what I'm telling Michelle is carpe diem, okay? Okay, get the broadband director in, get all the rules of the FCC, the Reconnect grants that are coming out of there from COVID, brokers these partnerships, sponsor business loans, incentivize the people here that have the right businesses here, and really invest in these live-in laboratories, and really promote manufacture of equipment like you guys are doing with the 3D printing. These smart poles that are coming out of Optipulse could be part of a 3D printing. Okay, we can really become a model for other states to duplicate. Okay, so we kind of put our brains together and said, how can we rise to the occasion of the New Mexico Broadband Initiative that Michelle Lujan Grisham has asked for? How can we do that? So we kind of looked around and we said, how can we do that? How can we do it? New Mexico Connect has about, they're a council, they have about 135 million right now. There'll be more as federal funds flow down. But how can we sort of not prevent, that's not the right word. How can we encourage collaborative groups to come together that have more comprehensive and more innovative solutions instead of everybody just going out for a pass and grabbing $1 million, okay? And then you've got disparate deployments across the state. So I had the fortuitousness of just kind of meeting Mathis, Chinook, and John Joseph from Optipulse, and just was blown away by their how brainy they are, but still humble, and also just that they would just be out there putting themselves out on the line to develop this stuff when it's not easy. And then they put me in contact with Sky, who does the high altitude platform stations that can fill in microwave bandwidth where it's spotty. And all of a sudden, we met John Badal from Sacred Wind, who's a visionary on this broadband stuff. And then he introduces us to Glenn Lovelace from Penasco PVT, and then to Guy Turley from Cellular One, SBI, Smith Bagley Incorporated. And then they introduce us to Gil Gonzalez, who's Navajo Tech University. And then Kimball comes in from Santa Fe Indian Schools. And then all of a sudden, yesterday, we have Ovidu from the public school facilities agencies, where they're trying to capture the school education network, okay, through the E-rate funds, okay. So we're trying to say, hey, if we all help each other, if we all care about each other, if we're not going to just go out for a pass for ourselves, how can we bring a whole vision, a whole plan, a whole deployment process, a whole innovation to Michelle Lujan Grisham instead of everybody just doing piecemeal? Okay, so that's what we did. We formed a consortium. So we are called the Broadband Initiative Consortium. Okay, we now have 8 companies and organizations, and they're all on, how many times a week do we meet now? 2, 3 times a week. They're all working together on this wonderful collaborative consortium. So when we got together, we all met at Sky out in Moriarty. We now added more people, okay? All right, so we all asked ourselves, this is what's called a reverse logic flow. This is how you kind of get to where you want to go. You start with, what's the end in mind? And then how do you get there? So we decided our end in mind was happy, connected people and attracting new business and workforce. And how do you do that? You deploy your access solutions and you grab the spectrum. There's a 2.5 gigahertz spectrum that's out there that's ready to be grabbed. It's already been grabbed on the tribal lands, and now it's been offered to non-tribal lands. That gives you the platform and the infrastructure to put all this technology on top of it, because it's reliable, it can go long distance, it gives you good enough speed and access to be able to layer your technology on top of it. So then you can prevent this monopoly of the big players and really get the heart of New Mexico working this. You've got to prove your concept, so we would put a proposal together to do that, develop the architecture and infrastructure, and apply for this grant through New Mexico Connect, develop this whole, deliver a plan and a vision for the governor, and then make sure we're in alignment with her big vision. So this is how we sort of came together. And then we said, you've got to put all of this in place. And so we would recommend to Michelle to grab the spectrum. That's not that big of a dollar investment. We would also recommend to her on the middle mile, the school education network is already building for the schools and the libraries fiber hubs, okay, from where you're really connected like Albuquerque, and then across the corridors like the I-40 and the I-25. You put these hubs in, and if you're already connecting to the schools, the universities, and the libraries, why not just put another connection point on there and be able to get the rest of the businesses? So you can leverage what's already coming out of the E-rate funds and build something in parallel alongside with a smaller investment that you would normally have to do, and then get these rural branches so that you can service the last mile with people like Optipulse and Sky, so you can get right to device. And where we want to come in, this is something you have to do, and is happening, okay? And we'll make recommendations here. But here is where we can add the innovation window that Mathis is going to show you today, okay? How do you do something high speed, lots of data, low latency, not dropping data, better than microwave, using microwave where you need to, like Sky can provide that, but then providing some other things where you can get right to the satellite if you need to. And that's where Mathis is going to come in and show you how to do that. And then how you do that is through something called technical readiness levels. We're probably right in here. And then someday we would grow it through testing and demonstration to get it all the way to a technical readiness level 7. So I'm excited today to be part of this consortium, excited here to talk to you here at New Collar, which is thinking outside of the box. And I want us to think outside of the box, and Mathis is going to show you how to do that. Okay? And I'm excited that we could rise to the occasion to meet Michelle Lujan Grisham's call to arms, her broadband initiative, and bring her a whole vision, a whole plan through a collaborative consortium, and be able to deploy something that grows New Mexico and grows their businesses like Optipulse at the same time. Okay. And so with that, I'd like to. Okay.
All right, so I'm going to talk about Optipulse, but and I first want to give a little bit of an oversight as to what Optipulse is. So we have an optical wireless technology, and a lot of times when you talk about optical wireless, you go back to the laser comm. You think about lasers, and yes, our technology is rooted in the creation of light, which is fantastic. And it's fantastic because it provides the ability at a very low cost, small form factor, and weight. It provides an ability to move massive amounts of data, billions of bits of data through the air. Right now, we see that and benefit from that with fiber optic cable. The light-emitting device that pumps that light through those cables is essentially the same technology that we have at the root, and we've taken that. John Joseph, the CEO and founder and inventor of this technology, has taken that and been able to develop it in a way that we can put it through the air. I'm not going to go into the technology first because I don't want to have everyone asleep at the beginning of this conversation. So what I'm going to do is I'm going to walk you through the way we look at this. Optipulse is a New Mexico entity, founded here, registered here. We're a C Corp. We have an investor base that is just brilliant for a startup company. We don't have any venture capitalists in there. We did that on purpose because John and I wanted to make sure we could control the destiny of the company. Getting to the point that you were making, Kelly, and what we see here, and kind of the grassroots effort to get to the benefits that we have, we didn't want to have the direction of the company pigeonholed into a sell to one of the big operators. It's been difficult kind of bootstrapping a company through all this, particularly a technology company that is not software, but is hardware. We make devices. We've done that because we have some fantastic support here in the state through individual investors. And we've done, and I'm going to show you some slides here, that we used when we went to a crowdfunding event in order to be able to capture the $100, $200, $500 investors that wanted to see our technology in their community. So I'm going to go ahead and run through this. So we know there's a high cost of broadband, and we notice the infrastructure is a part of that. When you think about it, the frustrations that you have come about because you don't have any real control over that, right? So when you get to the point where you're looking at the intersection of you working off of your device, right, and the data center or the cell tower or whatever that digital bit's going through, when you think about that, you often think about the urban environment and moving this around. Now, we play very well in the urban environment, you know, building top to building top, okay? But where's some of the real benefit at that level that, you know, we can do this, yes, but where's the real benefit that we're talking about from this collaborative effort to be able to reach all those parts of our state, our country, around the world, where you don't have that type of connection, okay? That's where we think we can excel. Optical wireless is everything. Of course, the inventor would say that. I'm going to stop us here because that is my finger. And that's the chip, the root of our technology. That just shows you how small that is. Now, when you start there with your light emitting device, a little bit of technology here, when you start there with that, then as you put the electronics to it to drive it, and you put the optical systems and mechanical systems in the housing, you can begin to realize why we're so excited about what we're going to end up with here. If you were to put over here next to that technology that is the existing laser technology that was used for wireless, optical wireless communication, you would have a much larger device. You would have a much more expensive device that uses a lot more energy to operate. So we start there, and that's the fundamental foundation aspect of what we've got with our technology. All right, so we're faster, we're inexpensive, and we believe that we can connect more people faster than other technologies. This is where we're going. That was out in Albuquerque. These are the devices, and this is the light pole that Kelly was talking about. So we've made several prototypes. Prototype 3 is what we're demonstrating there. We're finishing prototype 4. We'll have it here demonstrating shortly. Tomorrow. How many tomorrows are there? So our download speed is faster than 5G. I'm going to come to this whole 5G, 6G thing in a minute. Very low latency and very low cost. Now, so we think about it in the sense of who's going to benefit from this besides all of us, right? We have access sometimes, right? We have access, but who's going to benefit from all this? So I'm going to let these slides roll forward. And this was a take we did on our crowdfunding. And so you can see from what we've put up here with the benefit of this technology, and these are just little snapshots of where we think our technology can benefit. Are we being presumptuous in all of this? We don't think so. Primarily because a collaborative effort that we're doing here in New Mexico is going to be the showcase. The state's going to be the showcase, the participants, the community events like the New Mexico Tech Council. Deb is going to be very influential in that. What we have here going to Fab Lab Hub, all of that coming together, we think is going to make this happen. 6G. Now, we're bold enough to be talking about 6G because our technology is at the infrastructure layer, the ground layer. We provide the pipes. We provide the pipes that put that data through the air. You think about fiber cable and what that's doing. We do that through the air. We do it as fast as fiber, but we do it cheaper than fiber, and we use less energy to do it. So when you think about 4G, 5G, 6G, these generational transitions, where O-RAN is going and being able to create commonality in the way devices communicate with each other. And this is things when we talk to corporations like Nokia and Ericsson, Qualcomm, they talk about 5G with great expectation. They have factories that have communication networks inside those factories. The protocols and the addressing, the networking instructions that are in that sometimes can't communicate that factory to one of their others because of the different devices that they have. So Nokia, Ericsson, others are trying to work together to create the carriers. So we believe that if we can put down more lanes in a highway, increase the pipe, if we become that foundational infrastructure, then we're not really talking about 5G anymore. We're talking about 6G, 7G. Maybe the G goes away, and we're talking about just infrastructure, which we believe broadband is. We believe broadband should be available to all. It should be a utility in that aspect. Societal impact, we believe, is phenomenal in terms of the access. Here's some of the partners that we have. Here's the direction we're going with our spend plan. As a company, we're always looking for funding, particularly in our startup period. We are soon to be going back out again with another crowdfunding event. We've been able to raise capital. We've been able to increase our valuation, all those kind of fun things that as a corporate executive you think about, particularly because our shareholders can benefit. What I'll do now is take a little bit of a talk about the technology, just to touch on it. So when we talk about the funding that we've got, the benefit that we've got, we have about 95%, 96% of our capital, $4 million that we've raised to date, has come out of the state of New Mexico. C&M Ingenuity is an investor. The University of New Mexico, through their innovation fund at the foundation, is an investor. We have several rural telecom companies. Sacred Wind is an investor. Plateau is an investor. So we've been able to benefit from the support we've had in the state. And I'll segue from that into what we're doing with this collaborative group. Because we, as a manufacturer of technology, manufacturer of those devices that can provide that infrastructure, we as a manufacturer look to partners to help us advance that. And what we've got within the collaborative is the opportunity to work together to develop, test, demonstrate that we wouldn't have had if we'd gone out individually. So Sky, Sacred Wind, because we're bringing everybody together and we're starting to talk about what we need to do to demonstrate our technology, those companies are saying, well, we could provide you with the site for that, or we could provide you with some engineers to help you do that. That is extremely valuable for a company that's starting up. And also for them, because they get access to technologies. Also because that 95%, I've mentioned a lot of the big companies, but we have individuals. We have about 38 individuals that have invested in us that come out of our community. And now with what we did with the WeFunder campaign, and we're going to do now again with the next crowdfunding campaign, is we've opened that up to everybody that wants to be a part of this. So we got a massive number of $100 investments. We got another big number around 500, a couple scatterings up around 10,000. But it's that group of 100 to 500, it's that group of individuals that put the comments on that said, I want to see this in my community in Abiquiu. I want to see this in my community in Cuba. They didn't say, I want to invest because I'm going to make a lot of money off a $100 investment. They put the money in because they wanted to see this happen, and particularly within our state. And the WeFunder is interesting. The WeFunder campaign, a third of the investors that came in that campaign came out of New Mexico, even though it's a national distribution. So we're really pleased with what we got going here, and we think that this is going to be the moment with you, Kelly, that we've got going on this collaborative. So 6G, I talked about that. Again, the finger. This is the design. I'm going to go quickly into this because I think it's fundamentally important to understand. Somebody asked you, well, what's so good about Optipulse? Back in the late 80s at Sandia Labs, John Josephs and some others, our Chief Technology Officer, Jim Lott, and some others, got together to figure out how to create what's called a vertical cavity surface emitting laser. This is a device that's made at a semiconductor level. It's made out of 3,5 compound, gallium arsenide. It's not silicon, so it's a different sector of that chemical spectrum. They were able to perfect that, and that became what is driving, pumping light through all of our fiber cables today. That technology was essentially, each of these little dots here is a laser. It's a light emitting diode, is what it is at a semiconductor space. What they produced in Sandia was one of those dots on a chip like that, just one. As they added more dots, it began to slip in performance. So they could add dots, and they could get speed, but they couldn't get power, or they could do power, but they couldn't get speed. And that's important because speed is how many gigabits a second you can get through. Power is how far you can go with it. So John worked at it. He was a part of Mode, which was bought by MCore. He founded Trilumina, which was sold to Lumentum, in California. So he has an history in trying to develop this. He's got incredible clean room knowledge and expertise. But he kept at this. And up at CSU, one of the partners that he had from Sandia, he figured out how to put all of these VCSELs together in a single chip and drive them at the same time without losing performance. And so we do 19, 31, 105. We don't know what the limit is on how many of these VCSELs we can get on a chip. But we do know that putting 31, 61 on a chip, the more we get on a chip, the further we can go. So that is the technology. And it's fundamentally different than any other light-emitting technology, although the VCSEL is a common factor, but these are VCSELs grouped together in an additive manner. We put lenses on the back that we put lenses on the back of them so that we can direct the way the direction of the beam comes out. And so there's a lot more technology. I won't go into it, but I think this is very exciting. You can tell from a business perspective how exciting we think this is. We have chips right now that on a single channel, so just pumping one single channel, are at 25 gigabits a second. We actually have ones that are faster than that, but we haven't published that yet. But we have published that we can go to 25 gigabits a second, single channel. No RF device can do that. When we sat with the group at Sky, Gil Gonzalez, who's deep in this and was one of our technology advisors and still is, was talking about the fact that with RF technology, you can go 2 gigabits a second, but if you want to go distance, you can't go any faster. You can't go any faster than that. We can go distance and we can go at speed. And again, the size, the weight, all those kinds of aspects are things that we're very excited about. Here's the team. There's John on that end. We bring in a lot of advisors. Payman at the University of New Mexico, CHTM, has been a fantastic help for us on the high-speed electrical designs of our emitters and detectors. Kevin's up at CSU, a very good engineer in that design. Jim Lott has the world record speed for design of VCSEL material on a wafer. And that's important for us because we take that VCSEL material on a wafer and we make it into our chips. So this is the group, and Matt came to us. He was at Trilumina for a while. Before that, he was at Mode at MCOR. He is our optical engineer, and he's the reason right now that we are tomorrow going to have that connection set up here with our next generation device. Okay, this is just more of the data I'm happy to share with others that want to get into the technology. But what I want to say here is there's two important things on this slide real quickly. One is the way we do the lensing on the back of the chip. We can create what seems to be an overlap spot with all of those beams. So you got 61 beams coming out, little tiny beams coming out of that chip. We can create an overlap spot that we then project into the far field. And that's important because we're not projecting 61 beams. We're projecting a spot. Anywhere in that spot is the signal. Anywhere in that spot. So we project it out of here. We make it a meter on the far side. Anywhere within that meter, you have the signal. So if your detector is a 4-inch detector, the lensing on it, if that starts shifting because of wind or whatnot, as long as it stays in that meter, we have a signal. If on the emitter side, it moves a bit, as long as that spot stays over the detector, we have a signal. And that's important because rain, dust, snow, fog, the weather. How does this work with the weather? Because we have a beam and we're working at the speed of light, a single raindrop, snowflake isn't going to affect a dust particle. What about if it's raining heavily? Well, the way I look at it, if you can see a street light 100 meters, 200 meters, 300 meters away, a mile away, if you can see a light and it's raining or snowing or there's dust blowing, your eye is capturing that light. Your eye is our detector. Our light is invisible, you can't see it, but if enough of that light is hitting our detector, we have a signal. So that is one of the key aspects of this particular technology. The second aspect is we can put an array of these chips. So the chip itself has an array of VCSELs. We've created an array of those chips. We can create an array of array. And on the backside of all these chips, depending on how we put those lenses, and those lenses are made on a semiconductor process, so there's no external need, which is very important because the more you can do at the wafer scale, as you would know, Sarah, the more you can do at that scale, the less outside influence and effect you have in terms of causing disruption. So we can make that at the wafer scale processing. We then can have it such that each of those arrays in that chip would be going off at different areas, okay? We can use that for non-mechanical beam alignment. So you've got a chip there, you've got a detector out there, and you want to be able to align it immediately. Well, you just sequence through all those chips until you find the one that's made the connection. Non-mechanical beam alignment. We can also use it to create a field. The thing about our chip, and we're focused on communication, so we're focused on that high-speed communication, but these chips are also LiDAR. If you just essentially drive them slightly differently, you have LiDAR, sensing, tracking. So we can create a field with these chips all on the same time, creating a field so as anything that goes through that field, we can capture that it's happening and we can track it. Very, very valuable for some of our government drivers. So anyway, all this, what this does is it shows that we create these overlap points by the way we focus on it, and we can then create a way of non-mechanical beam alignment, sensing, tracking with these. So we are definitely light of sight, right? And mesh networks is our answer to that. And the other part to it is radio frequency RF devices, microwave, millimeter wave, up above a gigabit, going above that, are all line of sight as well. They cannot penetrate walls. So when you get into the point where you're comparing RF and optical, you start looking at that line of sight and you get up in the 10 gigabit space where we are and they aren't yet, you have line of sight issues. Now our answer to that is the size of our tech devices, the cost of our devices, the ease at installing our devices, the automatic alignment that we can do because of the non-mechanical beam steering, all that means that we can put up our devices more, faster, quicker, cheaper than we believe that can happen in the RF side. Now, one of the things that RF can do is they can get up to 10 gigabits, but they have to multiplex that or put multiple devices, again, adding cost. Our current generation device operates at about 13 watts for a link. A lot of the RF devices are 30 watts and above. So our power consumption is done. Our manufacturing can be 3D. So we're in the process of having a greener, lower carbon footprint. We haven't measured that because we're just focused on getting the device out. But we have that. But line of sight is going to be a constant issue. And so this is where, when we think about applications and the number of schools in New Mexico that have 10 gigabits of fiber coming to them, the rooftop of that school, we can go to a community center, we can go to a pole, and off of that pole, you can then have the RF device that connects to your cell phone, that connects to your house, that connects to your laptop. So we have government contracts. We have a number of different applications, both with our light pole. We think that the ability to have this far field spot and sensing has a lot of attraction. So I'm not going to go through some of where we are with our development plan. If anyone is interested more about Optipulse, I'd be always happy to talk to you. Our color is green, so is investment money. Space, coming back to final point, we have a lot of open expanse here in New Mexico. We believe that we can get to a point where we can do 10 kilometers, 20 kilometers. That is part of our development plan, is part of what we're looking at, working on with the partners in the collaborative effort. We believe we can do that, but we don't have to do it immediately because there are options. The high altitude airship is one of them. Satellites are another one. So we put in a plan to be able to support those entities, a Sky, a Sacred Wind, support those entities with a development path that gets us to 65,000 square feet, which is where the high altitude airship is going to be. Gets us to LEO, which is 1,000 kilometers, so that we can then, and also go satellite to satellite. And we have some negotiations and discussions with NASA right now in order to do that. So we are very pleased to be here in New Mexico. We're very pleased to be at the Fab Lab Hub. And I've got to say, Sarah still is very kind to us, even though we stole one of her key people. And we are doing, oh, those laser people. You do. But I'll make a plug for what's happening. All of the work that we've done over the past couple of months is because we have two individuals, one that is a design engineer operating the high-speed, the printing that we're doing, the 3D printing, and one's an optical engineer putting that all to work, along with our electrical engineers. And the progress they make day by day by day, which would have taken us weeks or months if we'd gone out to a machine shop, is just phenomenally beneficial for a startup company or turnaround time. So anyway, a plug for Fab Lab Hub and all that it does.
That was really great. Yeah, and I would just add to what Deb was saying. The reason that Santa Fe Community College and I felt so strongly about creating an innovation center is that we believe it's innovation that solves problems. And in the world today, there's so many problems, I mean, between climate change and COVID and everything else, and you're not going to solve them doing the same things the same way. And as we all know, strategy is not doing more of the same. Strategy and innovation are about doing different things. Thinking outside the box, I think, is how Kelly put it. And it's coming up with those new solutions. And we want to be a shining light here in Santa Fe as a place where innovation can be encouraged to happen. So thank you for coming, and we'll keep moving ahead. Thank you.